Good morning and welcome to the video for Monday, August the 3rd. I have a special guest with us today that most of you are probably familiar with. This is Ernie. He's our half Greyhound, half Great Dane, and we are watching him for the day. So he gets to buy into the videos so he could be on camera, as I got to have him on camera for a lot of the videos in the spring, especially the earlier set of videos. So today we're going to do our last video for the summer. There are so many different things with the last in our book, which continues statistics, that I could probably do a separate video for each of those, but I don't think we're going to get a lot of benefit out of doing that right now. Once we get into the school year and we start working through all of the different things that you'll need to know, and we get to that part in the book, that would probably be a better time to do that. But I want to show one more thing today, which talks about patterns in the data. And so we can see that both with our dot plot and with our histograms. And so let's take a look at that. And so to start with, we have this histogram that shows pumpkin weights. Most of our pumpkins are between 21 and 30 pounds. We have a few that are between 0 and 10 pounds, a smaller variety, and we have some really large ones as well. But we have a definite pattern, and so the peak is going to be the top portion. In some cases, it's going to be in the middle. In other cases, it might be at a different point on the histogram. So we could actually have the peak here or out here. Any of these 5 sections could be the peak potentially. Or we could have more than one. And so the interval representing the greatest number of pumpkins would be between 21 and 30 pounds. And so we're going to talk about how the data changes. And so if we start from here, we kind of are making a slope upward. And so we would be increasing until we get all the way up to the end of our peak, which would be at 30 pounds. And then it goes back down, and so we could say that it decreases or gets less. If I drew a vertical line through here down the middle, this particular side is going to look rather similar to this side. There is going to be a slight difference. This part here doesn't come down quite as far as this. So if I drew a straight line in red across here, well, if I drew it straight, that being the key problem, this part's going to be a little bit different, but that's not going to change our symmetry that much. So that's kind of what we're looking at for that. We would say that this histogram has symmetry. And it's just based on the general shape. It doesn't have to be exactly perfect. And then our data values increase to one peak, and then they decrease. And so we would say that the data set has symmetry. Our other thing that we're going to look at are different things that we can talk about with a dot plot. And so again, our dot plot was a way of representing the exact values, where a histogram gives a range, but not the specific values for each data point. And so a gap is going to be something that we're going to look at that there is no data for. So our gap would be between 8 and 10 inches. And then we are looking for clusters. And so clusters are going to be where there's groups of values. And so we could say that this would be one of our clusters, and this would be another cluster. Even though there's only one value for each of these represented, that would be part of this grouping. So we kind of look to see if there are any closely packed groups, and then if there are any gaps when we're looking at that. And that helps us answer a couple different things about our dot plot or our data. And so I'm not going to take the time to write all those in. Our first one would be from 5 to 7. Our next one would be from 11 to 14 for the clusters. And so we could answer different questions like, why might there not be any values for this? And one of the reasons for that, if we look at our example, we are catching potentially 4 different types of fish, but if they don't catch any of a certain type of fish that might be in this particular range, or you catch a younger version of that would be a smaller fish, then that would be a reason why we might not see a value represented for those particular lengths of the fish. So that kind of covers an introduction to that part. There are so many other things that we could talk about. One of the things that I might do for Thursday is it's not going to be tied to a specific lesson, but I may make a follow-up video that explains why we talk about statistics, because that is going to be a lesson that we have, but I don't want to take the time to go through each individual thing that you would have to know to be able to understand the problems that show up in that particular lesson. So I may give a real world example of why it's important that we know about statistics and how to take a look at data so that we can make accurate representations of what that data is supposed to mean. So I'll look at an idea for doing that using some real world examples based on things that are going on right now, and talk about how the numbers may represent one thing versus another. Sports is a really good way for statistics, but not so much for the type of thing that we would be talking about. So if you're a sports fan, know that the sports numbers for the statistics are very good for doing some of the things that we've been working on, but not necessarily for talking about why we need to know them. How do we keep from falling victim to someone misrepresenting information by trying to use statistics? So that's kind of the idea that I'm looking at for Thursday. So I'll think about that, and then I will hopefully do that on Thursday. If not, I wait until Monday, but you guys will be the only one that I will have a video for on Monday if I don't have one on Thursday this week. So hope your summer is going well. I'm looking forward to see you all again, and I look forward to seeing you in the next video, which will hopefully be on Thursday.